Okay, so for this particular lesson, we're going to learn how to calculate percent value. And there is a formula that we need. Before I do that, though, let me give you some information, some given information. We're going to figure out how much money should be deposited today in an account that earns 4% compounded semi-annually so that it will accumulate to $16,000 in 3 years. Okay? So here's what we're going to do. We're going to first label some things, identify some things, okay? So we want to know how much the money will accumulate to 16,000. So that's going to be the future value. All right, and that's going to equal 16,000 because that's what we want to know when it accumulates to that level. So that's future amount, right? And we already want to know the rate. We said the rate was, by the way, the future value is going to be A, right? So this will be A. A equals future value, which equals $16,000. The rate we said was 4%. So we're going to convert that to a decimal. We'll do that now. 0.04. And then the time, going to be 3 years. All right, so because the interest is compounded semi-annually, that means twice a year. Semi-annually means twice a year, and has to be 2. All right, so here's the formula that we need to use. The principal formula. Okay. So when you want to find out how much will accumulate to a certain amount, we're going to use this formula. And now once you have the formula, it's just a matter of plugging everything in and calculating it. Okay. So we know the A is going to be 16,000 divided by 1 plus. The rate we said was 0.04 divided by 2 raised to the n. So we said n was 2 and the time was 3 years. Okay? So here's how we do that. 16,000. Okay. Once we do 0.04 and divide it by 2 and add 1, you're going to get 1.02. Okay? And then 2 times 3 we know is going to be 6. So we raise that to the 6th power. Make sure that's in the denominator. Make sure you raise 1.02 to the 6th power, not 16,000. So we're going to divide these two values. Okay? Once you take 1.02 and raise that to the 6th power, you'll get a number. You take that number, right? You take that 16,000 and divide it by that number you get. So it's going to be, actually, you know what? Let me go ahead and give that number to you. Okay, so we're going to do 1.02. Going to raise that to the 6th power, right? Times that by, okay, never mind. Okay, so then we take that number and divide it by 16. Okay, so 16,000. Okay, so we got 16,000. You divide that by, and you take 1.02 raised to the 6th power. I got 1.12, 616, etc., right? All right, so then we take that answer, 16,000, and you divide it by 1.12, 616. You will get $14,207. and 57 cents. Or 55 cents, sorry. Okay, so this is your amount. This is what it will take. It's what your principal would be. Like your principal, this is what was given, and then add a 4% interest rate over 3 years. This what would have been the initial principal, right? Obviously, it's going to be less, right? It should be less than 16,000. If not, then you did something wrong. Okay, so logic tells me that it's going to be less than 16,000. Okay, and so it's pretty easy to do. You just have to use that formula. So then you get your answer. Okay, so now. That's it, actually. There is no more. That's the answer. Okay? All right. So we can be able to calculate that using that simple formula. Now let's do one where we determine the effective annual yield for each investment and then select the better investment. Assume that 365 days in a year, okay? Well, we know that, right? 15% compounded monthly, and the other one is 15.25% compounded annually. So we want to figure out, okay, we have an investment that has a nominal interest rate, okay, in decimal form and pays compounded interest n times per year. All right, the investment effective annual yield, which is Y, is given by the following formula. Okay, so let me go ahead and write that down. Oops. -1. Here we go. Okay, and by the way, nominally means a price or amount of money very small, far below the real value or cost. Okay, so just make sure you understand what that means. All right, so here we go. That's the formula we need. So let's figure out what we're asking to do. Okay, so first we're going to find the effective annual yield. So we're going to find the effective, not the way that's written here. Sometimes this pen slips and makes it really challenging to write. Okay. For this is one of the given problems for an investment. At 15% a year. %, 15%, and it's compounded monthly. Okay, so that's one of the situations. That's the first one that I said at the beginning of the video. All right, so when we have this situation, we're going to use this formula. Right? And that's the difference. So every situation is going to have a slightly different formula. All right, and these are the ones. That's why there's 4 formulas, right? Depending on the situation that's given. Once you are familiar with the situation, just use these notes, and then when you do the homework, it'll fall into place for you nicely. Okay. So now just plug in everything that's given. Okay, we know the rate is going to be 15%, so just convert that to a decimal. That's 0.15. All right. Compounded monthly, well, n has to equal 12. Whoops. Okay, n has to equal 12. All right. And yeah, that's pretty much it. Okay. So here we go. Let's plug in some numbers. Two raised to the second power minus 1. Okay, so we substitute everything in. Now we're going to simplify it and then convert it to a percent. So if you take 0.15, divide it by 2, and then add 1, you raise that to the second power and then subtract 1, you will get, you'll get 0.1608, I think, and you convert it to a percent, which will be 16.08%. Okay? So I'm assuming that you're comfortable calculating the values in the formula. It's just a matter of order of operations, right? Do the division inside the parentheses, add the 1, then then add the 1, and then raise it to the second power. You'll get a number, and then subtract 1, and you'll get your percentage. All right? So now we're going to find the effective annual yield. All right, and the investment's going to be at 15.25%, because that was the other situation that was given to us, right? And it's going to be compounded annually. So let's make the rate a decimal, which is 0.1525. N is going to be annually, so that's 1. Okay? And then the rate is that, 0.1525. N is 1. Now we can calculate the effective annual yield. Okay? All right, let's do that. Let's get that done. Let's see here. So we're going to have, now we use this formula here. Plus. Okay, it's going to also equal the rate. Okay, so here's how this works. You note that for any rate R compounded annually, the statement below is true. That's this formula here. Okay, so since the interest is compounded annually in this investment, the effective annual yield is the interest rate, which is 15.25%. The effective annual yield for the first investment is 16.08%. Okay, so the effective annual yield for the second investment is 15.25%. All right, and 15% compounded annually is better investment because the effective annual yield for the first investment is higher than the effective annual yield for the second investment. I know it sounds kind of weird, but so the effective annual yield is going to be equivalent to the rate because the interest is compounded annually is the investment. Okay. So, yeah. So the effective annual yield, it's just what I said. So this is the magic right here. So I'm gonna write this down. Since the interest is compounded annually in this investment the effective, let me write that here. The effective annual yield is the interest rate, which is going to be 15.25%. Okay, so therefore, so we say the first conclusion, the first. Oh, anyway, sorry about that. Okay, so the first investment %15 compounded monthly. I'm so sorry. I'm just like the marker is sliding on me. Let me see if I can get a better grip here. I'm sorry about this. Okay, so the first investment at 15% rate compounded monthly. Sorry, gosh. There you go, much better. Is better is the better investment. Okay, and that's because the effective annual yield for the first investment is higher than the effective annual yield for the second investment. All right. Okay. All right, so that's how you do that one. Okay, so I hope this particular video helped you to some degree, I hope. Okay, and we will go over some more things in future videos as well. All right, I hope you enjoyed this, and hopefully it helped you a lot. You have a great day.